Hello friends, welcome to our channel. Let's have a look at today's daily challenge problem. So here we are going to construct binary tree from preorder and postorder traversal. Here let's look at one example. So let's use example 1 to demonstrate the idea. So notice here, this is the definition of a tree node class. It has three attributes, value, left, and right. So this is well known. So here, if you look at the preorder and postorder traversal, so basically from the preorder traversal, so you know the root value of the tree is 1, right? So then if you we pop the 1 from preorder, so let's update this. It's going to be this, right? And then also in the postorder, the 1 will be in the tail. So if we pop it, it's going to have like this. So then so this 2 will be the left subtree root, and here 3 will be the right subtree root in the postorder, right? So the right subtree value will be 3. And then from this 3, because here we assume that the binary tree has distinct values, so we can locate the position here in preorder, right? So you can get using index to get this. Then what we get? So locate the position of 3 in preorder, right? So then this 2, 4, 5 is the preorder traversal of left subtree. So similarly, from this, because the length will be 3 due to the index, this guy 2, 4, 5, 2. So this will be the postorder traversal of left subtree, right? Now similarly, you can get the preorder traversal of the right subtree. Right subtree is going to be 3, 6, 7. Let me copy this here. And so here, this will be 6, 7, 3 will be the postorder traversal. So this way we noticed we know all the information of the trees. In other words, the first element in the preorder will correspond to the whole tree root value, and then using the second to last element in the postorder, we can locate the right subtree root, and then from the right subtree root we can distinguish the left subtree and the right subtree traversals, both in preorder and postorder. So this is the way we are going to write the code. So example 2 actually is a special case, just length 1, right? It's just the root value. So now let's write this solution in the recursion format. So notice that when you write recursion format, you need to have a stop condition or bounding condition. So here first, if not preorder, right? So we just need to return none or just return. So this is the very important, right? So next, what we want to do is first get the root value. The root will be tree node, and then the value will be preorder at index 0, right? So now we get the information for this. We can actually pop this guy, pop 0. But in postorder, actually we need to pop just pop from the tail. So pop. So this way, then we can get the right value, right subtree value. That will be postorder at -1. So here actually we can see, we can first do a check. If not postorder. So in other words, the tree is just a root value. So we just need to return root. We don't need to specify the left subtree and right subtree of the root. Otherwise, so we can do this, right? Because it's not empty. So then we can get the index. So pre-order index right value. So you can think of the 3 here, right? So now once we get this, then we can do left subtree traversal and build the left subtree and the right subtree. So basically we call the self call of this method self. So what's the pre-order? So pre-order, so it's up to this index. Similarly in post-order, so because the two strings, the two lists should be seamless, so we write idx here. And then similarly we do this. So, but now I write it like this. So the reason I do this pop operation in pre-order and post-order is here. This pop operation will make this call here very clean, right? You just need to up to index and then up to index and then from index onwards, right? So once you do this, you do root left equals left, assigned to be left, and root right to be right. And then you just need to do the return the root. So that's basically about it for this problem. Now we can do a test run. Pre-order is not defined. So let's see in pre-order, right? Let's run it. Pre-order is not defined in 42. Pre-order. Still pre-order, right? So now let's see. Yeah, it passes the 2 test cases. Now let's look at the generic case. Yeah, it passes the cases very fast. So here is one thing. So some people may think that I use pre-order pop from 0. It might be slow. So if you want to change this operation a little bit, you can make pre-order and post-order a deck. So basically pre-order is you can make it collections default deck from pre-order, and then same thing for post-order. So now what do? You do pre-order pop left. So this will give you 01. But here still you can see it's runs reasonably fast due to the problem size. So basically I will content ourselves here for this problem. So yeah, I guess also yesterday's problem is also about construct the tree, but from a serialization. Next video we're going to look at that problem. So if you found the video is of use, you're welcome to also digest some other videos in our channel or share with your friends or classmates. Thank you.